Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I am going to present about final project report, which is an introduction for mathematics for built environment. In our project is about under the trigonometry topic. So the project is prepared by Diana, Adrian, Natasha, Uncle Rina, Jasmine, Sophia, which is me, and Mona Shafika. So mathematics solve problem by using logic. One of the main tools of logic used by mathematicians is deduction. Deduction is a special way of thinking to discover and prove new truth using old truths. So in the 7th century, mathematicians began working with trigonometry that required the measurement of angle and the computation of trigonometry function, which include sine, cosine, tangent, and their reciprocal. So through this study, we can see how trigonometry is applied to solve a problem that affect our daily life. So the objective is to allocate the best way to solve this problem, to apply mathematical calculation and method in solving problem, to provide safer and high compatibility of component to the user, and give the right solution so that it will give the benefit to the user. So first case, the steps. The step should have its standard measurement for every step, and the application of theorem Pythagoras to build stairs are needed as it keeps the cells stable and users use the stair without facing injury. It should have proper measurement, follows trigonometry and Pythagoras law. So the problem statement is the stair is too high and dangerous as it doesn't have any handrails, so it can cause harm for the user, especially kids. The measurement of the stair treads and riser are quite small but stay in the same measurement. It should be considered the suitable size of all edges. And the stranger of the staircase is too thin and thread is not too thick enough to hold the occupants that will cause several dangerous situations. The procedure is, as you can see, the problem statement is the staircase is too steep within the original measurement that causes dangerous situation. So the solution is to add the length, thread length, and the thickness of the staircase. So procedure 1, measure the height and width of the staircase using measuring tape and record the data. Second, the data is used to calculate the stringer of the staircase, and third, gives the solution by comparing the original measurement to the redesign the staircase. So how to calculate is multiply the tread and riser with 12 stairs to get height and length of the staircase. The riser height is 200 mm. The staircase height using riser measurement is 200 mm multiplied by 12 stairs equal to 3000 mm. And the tread length is 300 mm. The staircase length using tread measurement is 300 mm multiplied by 12 stairs equal to 3600 mm. So to know the stringer of the staircase, you need to use the theorem Pythagoras formula, which is that. So how to know is 3000 square plus 3600 square divide and make it root equal to 4686.15 mm. So as you can see, the original stringer we get from before this is 4686.15 mm. So this step is very important for us to know how to approximate how many woods to buy from the manufacturer. So the solution of this problem is to add the original staircase length with the new length of staircase length multiplied with the same 12 square, which is and as we can see, the riser height you should have no stringer, which is 200 mm, and the staircase height using riser measurement is 250 mm multiplied by 12 stairs equal to 3000 mm, which is the same one. And the tread length is if you want to know the staircase length using tread measurement is 300 mm plus 50 multiplied by 12 stairs equal to 4200 mm. We can see that there is an addition of 600 mm. If we subtract the new one to the new one is 4200 mm to the original one is 3600 mm. And if we add 50 mm to the original staircase length, the stringer length also changes. So to know the measurement of the stringer is to use the theorem Pythagoras format 2 equal to 3000 square plus 4200 square make it root equal to 5161.4 mm. So to make sure the wooden staircase is strong and stable, we need to add thickness of thread without any addition of stairs. So add 20 meter thickness to the track. Okay. So as we can see, the original thickness of thread is 16 millimeter. So we need to add 20 millimeter to it to make it stable. So let's say the approximate amount of the wood to order. First, we need to subtract the new length of each stranger with the original length, which is 5161.4 minus by 4686.5 millimeter equal to 475.25 millimeter. And to know the exact amount of wood or to order is 475.25 millimeter plus 80 millimeter, which is we get from the new thickness of thread equal to 555.25 millimeter. So in conclusion, the turnaround bit, the wooden staircase, we need to buy at least 560 millimeter of wood. And so, second case study, the ramp. Introduction. A ramp is an architectural element that connects two levels with different elevation, as it is alternative to stairs for those who have mobility problems due to sloping surface. So a ramp should have its standard measurement. So in our studies, the problem statement is the ramp is higher compared to the standard measurement. Thus, it could problem for the user to park their cars into their house as it uses high oil pressure to climb up the ramp. And also, it's not really safe for children when they want to go down the ramp while riding their bicycle, even though they have a brake. So the calculation of the ramp should be done with suitable measurement. The procedure is the height and the width of the ramp are measured by using measuring tape. From that, we can already calculate the width of the concrete slope. So the solution is widen the base of the ramp as the height cannot be changed. So as you can see, diagram 1 is the ramp. So we need to find the angle of the slope using the measurement. First, find the angle of the slope. How can we calculate it? Is sin theta equal to 30 divided by 92 equal to theta is 0.32608 and make it sin negative 1. So the angle is 19.03 degree. So how to make it y? So you add 18 centimeter to the length of the base of the ramp. Means calculate again, 82 centimeter plus 18 centimeter equal to 100 centimeter. So diagram 2 shows that the new measurement of the slope. So when we see in the diagram, the slope is already have the longer, wider length. So how to know? First, and we need to know the hypotenuse. So apply the hypotenuse, the theorem Pythagoras concept, which is until you get the answer is 104.40 centimeter. And then we need to find the angle of it as sin theta equal to 30 divided by 104.40 and make it sin negative 1, shift sin. So you get 16.7 degree. So the new measurement is the height is still remain the same, 30 centimeter. The length is 100 centimeter and the slope is 104 centimeter, which is 12.4 centimeter more longer than the previous one, and the angle is 16.7 degree. So the more longer of the hypotenuse, the more smaller of the angle became, and the more stable it is. So in conclusion, to renovate the ramp, we need to add a measurement into length of slope to make it slope longer and safer. So it will decrease the use of oil pressure for vehicle and safer for the users. So conclusion, every problem in our house should be solved by applying mathematical calculation. More importantly is we manage to ensure the safety of the user. So this project is really important for students to find best solution in every problem and to take care of for the safety of others. I think that's all.